What's up guys, welcome back to my data structure playlist. Today I'm going to talk about the operations of circular linked list. I have already discussed what is circular linked list and the structure of it. So if you haven't seen that video, check out my data structure playlist. There is a link in the description below. So without any delay, let's get started. So circular linked list may be two types. Okay, first of all, the circular linked list can be singly circular linked list and the others can be doubly circular linked list. So we will not make it more complex. We will see the operations of singly circular linked list only. Right. First of all, we will see the insertion operation. We can do insertion in a circular linked list in three ways. We can insert a node at the beginning, at the end, and at an internal position, as we have seen in singly linked list and doubly linked list video. So in circular linked list, we all know that nodes are linked with each other by creating a circle, right? So like A is pointing to node B and node B is pointing to node C and node C is pointing to the node A again, right? So this is a circle linked list which contains three nodes and creating a circle, right? So in this circle linked list, we want to insert a new node D at the beginning position, right? So for that, first of all, we have to give the address of the node A into the next pointer of the node D, right? We have to maintain the circle also, right? For that, we have to give the address of the node D, which is the first node, into the next pointer of the last node C also, right? Then we have to change the direction of the head also. We have to give the address of the new node into the head. Then this prepend operation will be completed. So then let's proceed into the append operation, which is insert a node at the end position. Suppose this node D we want to insert at the end. So to insert at the end, first of all, we have to give the address of this new node into the next pointer of the previous last node, which is C. We have to maintain the circle. So for that, we have to give the address of the node A, which is the first pointer, into the next pointer of the node D, which is now is the last pointer, last node, right? So in this way, the append operation will be completed. Then let's see the insertion, which is insert a node at an internal position. So suppose we want to insert the new node G after node A and before node B. We can do this in the same way as we have seen in the singly linked list video. So for that, we have to make the linking of node D and B. Firstly, we have to give the address of the node B into the next pointer of the node D. Then we have to make the linking of node A and node D. So for that, we have to give the address of the node D into the next pointer of the node A, right? Then this link will be cancelled out and then the insertion operation will be completed. Now let's see another operation, which is traversal operation. So traversal operation is the same as single linked list. We can traverse the circular linked list as the same way in of the single linked list. There is a single small difference that in single linked list the next pointer of the last node is null, right? But in circular linked list there is no null. We have the first node into the next pointer of the last node again, right? So for that we have to somehow maintain the loop or anything that we can traverse the whole linked list and print all the value. So this is all we have talked about. So now let's jump to the implementation. I have already done the basic stuff. Firstly, I have declared a data of circular linked list class type. Then I have done a do while loop, inside which I have firstly command out some lines. Firstly, press 1 to insert a node at the beginning, then press 2 insert a node at the end, then press 3 to insert a node at an internal position, then press 4 to traverse and print, press 0 to exit. Then we will command out a line to receive the option from the user. Then we will receive the option. After that, if the option is 1, then we will call a function insert beginning function. Inside this we will do the insertion. But if the option is 2, then we will call insert in function. If the option is 3, we will call insert internal function. Option is 4, if the option is 4, then we will call a traverse function. If the option is 0, then we will break the loop. So if there is press any other options without this, then we will say that invalid option and to enter a valid option. Okay, now we have to create the circular linked list. Then we have to create these four functions also. So first of all, we have to create node, right? We have to create node class for that. So then let's make all the members public. So in a node of a circular linked list, we all know that we have a data field integer. Then we have a next pointer, which is another node type. This is all node class. So then we have to create the circular linked list class also. Make all the members public. Then make a head pointer. So first of all, we have to make the head by default null. Okay. So whenever we will declare a data of circular English class type, automatically the head will be null. So for that, we will make a constructor. This is as the same name of class type. Okay, we will make the head null. Now we will make we will make for those four functions. Firstly, we will make the insert beginning function. Firstly, we have to receive the value of the new node, right? That the user want to insert at the beginning. So for that, we will command out a line and enter the value of the new node you want to insert. Then we will receive the value. Now we have to create the new node. We will create it dynamically. So why we create it dynamically? Because whenever we have to delete the node, we will delete it from the memory, right? So if we create it dynamically, then we can delete it from the memory. But if we create it statically, then we will not remove it from the space. So in C++, there is a keyword which is new. We can use this to make data dynamically. Okay. So we have to make the data equals value. Suppose if the circular linked list is empty, then what can we do? Then this is the only one node, right? We have to insert. So then what will be the structure of the circular linked list? Suppose this is the single node we have to insert. What will contain the next pointer of the node? It will contain the address of itself. Okay, because there is no node, right? So it is the first node and it is also the last node. So the next pointer of this node will be pointing to the first node, which is itself. If the circular list is empty, that means the head is null. Okay, so firstly we have to make the head to the pointing to the new node, right? Okay, then we will make the next pointer of the new node to be pointing to the head again. Right, then we will return. Now if the circular list is not empty, then we have to make some linking, right? Suppose we have some nodes in a circular list. 1, 2, 3. Okay, we have 3 nodes. Okay, this is head. So we want to insert a new node at the beginning position, which is before this node. Okay, so first of all we have to give the address of this node into the next pointer of this new node, right? We have to make this linking. Then again we have to cross this link, because this will be the pointing to the first node, right? So this is not the first node now, the first node is this now, right? So we have to give the address of this node into the next pointer of the last node, right? So this is all we have to do. First of all, we have to give the address of the first node, which is head, into the next pointer of the new node. Okay, now we have to go through a loop to find the last node, right? When will we find the last node? We will find the last node when the next pointer of the node is head, right? Because it will be pointing to the first node again, right? So the next pointer of the node will contain head. So uh, we will make a temporary pointer firstly. So then we will go through a loop till we get the head, till we get it into the next pointer of it, not equals. Okay, then we will go to the next node. In this state we have reached the last node, right? So we have to give the address of the new node into the next pointer of the last node, which is temp, right? Okay, then we have to change the direction of head also, right? We have to change the direction to be pointing to the new node. Okay, that's all. Now let's make the insert end function. Okay, firstly we have to receive the value of the node that the user want to insert, right? So for that we will command out a line, enter the value of the node you want to insert. Then we will receive the value. Okay, now we will make the new node. We will give the value. Suppose we have these nodes in a circular linked list, these two nodes. Okay, we want to insert a node at the end, right? We want to insert a node at the end. Okay, so for that firstly we have to make the linking of this node and this node. Okay, so we have to give the address of this node into the next pointer of this node. Then we have to make the linking of first node and last node also, right? Because we have to maintain the circle. So for that we have to give the address of the first node into the next pointer of the last node. Okay, this link will be cancelled out, right? So then this will be completed. So first we have to traverse the linked list to find the last node, right? So we will go through a loop till we find the next pointer of the node is null. Firstly you have to make a temporary pointer. Then we will go through a loop till we get the next pointer of the node is head. Okay, we will simply jump to the next node. In this state we have reached the last node, right? Okay, first of all we have to check that the linked list is empty or not, as we have done in the insert beginning function, right? So we will do it firstly. So we will check that if the head is null or not. So we will do the same thing as we have done in the insert beginning function, right? This thing, because this is the same thing we have to do in the inserted function. This will be the only on node, right? Here when we will insert this. So Firstly, we will give the address into the head. Then we will make the next pointer of the new node to be pointing to the head again. Okay, then we will return. Now after that we will go through a loop to find the last node. Then we will make the linking. So first of all we will give the address of the new node into the next pointer of the last node, which is temp. So we will give it. Then we will give the address of the first node into the next pointer of the new node, right? So which is it. Okay, this linking is completed. And then let's make the insert internal function. So suppose this is the circular linked list. So we want to insert this node at any internal position. So we want to insert this node after this node and before this node, right? We can do this in two ways, as we have seen that we can insert this after this node and before this node. So we will do in the first way. This is the more easier way, right? We will do the more easier way. So firstly we will receive the node which after which the user want to insert this node. We will receive this node. Then we will go through a loop to find this node. After that we will make the linking. Firstly we will give the address of this node into the next pointer of this node. Then we will give the address of the new node into the next pointer of this previous node. Okay. So first of all we will receive the value of the node, after which the user want to insert a node. Okay. So enter the value of the node, after which you want to insert a new node. Then we will receive the value. Then we will go through a loop to find the node, right? So we will make a temporary pointer. We will go through a loop till we get the next pointer of the node is null. If we get the expected value, then we will break the loop. If this is not the case, then we will go to the next node. If we have got the expected node, then the next point, then the data field of this term should be equals to value, right? So if this is not the case, then we will print out that the invalid node the user inserted, right? So we will check that if the data of the term is equals to value or not. If not equals to value, then we will print that invalid option, invalid node. Then we will return. Okay, if this is not the case, then we have already found the node, right? Now we have to receive the value of the node the user want to insert. Okay, so for that we will firstly command that enter the value of the new node you want to insert. Then we will receive the value. Now we have to make the new node. Okay, now we will give the value. Now we have to make the linking, right? So we have already reached the node after which we want to insert the node. Okay, this is 10. Firstly, we have to link the second two nodes, right? We have to give the address of the next node into the next pointer of the new node, right? So we will find it into the next pointer of the 10, which is previous node. Okay, so we will give it into the next pointer of the new node. We will find it into the next pointer of the temp, which is previous node. Okay, this will be next. Then the second two nodes linking is completed. Now we have to make the linking between first two nodes, right? We have to give the address of the new node into the next pointer of the temp. Okay, so this is all we have to do. Now make the traverse function. So this is same as the singly linked list. So firstly we have to create a pointer, temporary pointer. Now we will go through a loop till we get the next pointer of the node is head in this case, because circular linked list count is no null, right? So then we will print the value. Then in this state we have reached the last node, right? So we have not printed the last node yet, because whenever we will reach the last node, this condition will not be fulfilled, right? Because the next pointer of the last node is head. Okay, so whenever we will reach the last node, this condition will not be fulfilled. Then we will not go inside this function. We will break through the loop. So now we have to also print the last node value. Okay, so we will find it into the temporary pointer data field of the temporary pointer. Okay, now we'll print out a looking line. So this is all the circular linked list. Now let's run the code. Okay, there is an error. Redeclaration, which is 94. Okay, we have already declared it in here. Okay, let's run the code again. Seems to be fine. Suppose we want to insert firstly 9, then 11, then 10, then 12, then 8. Okay, so firstly we want to insert at the beginning, so press 1. We want to insert 11. Okay, let's check it. Fine. Now we want to insert at the end. We want to insert 8. Now let's check it. Okay, this is an infinite loop, I think. Insert in function. Okay, this should be not equals. Now let's do the code. Press 1, then insert 11 at the first position. Check it. Okay, let's insert at the end. Press 2, then insert 8. Okay, let's check it. Okay, now it's fine. 11, 8. Now we want to insert an internal position. Let's press 3. We want to insert after 11. So now we want to insert 10. Okay, let's check it. Okay, 11, 10, 8. Right, now we want to insert at the beginning again. Press 1. We want to insert 9. Let's check it. Okay, 9, 11, 10, 8. All is fine. We want to insert at an internal position again. Press 3. We want to insert after 10. Okay, we want to insert 12. Now let's check it. Okay, 9, 11, 10, 12. Right, all is fine. So press 0 to exit. So this was all for today. We will see the deletion operation of a circular linked list in the next video. If you guys have any doubt or question, you can ask me in the comment section. It will be a pleasure for me. Till the next video, keep enjoying and thank you for watching.